there is a tool that we use every day, and we don't really think about it. And this tool is Git. All right. Um, Git is actually a pretty fantastic tool. And we use it every day, and we don't really pay attention unless we get into like a weird rebase type of thing. But most of the time, it flows okay. Um, it is a great tool because it gives you a full history of your code base. When you look at your code base in your text editor, you see the current state of the code base, but you're just like one git log away to figure all the changes that have happened for like years on your code base. When you look at the git log, you can see like who made the change, when the change was made, what the change was, that's like the description, why the change was made, that's a very good description, and how the change was made. And so the how is like the git diff. And that gives you like a lot of um, knowledge and insights into like how we got there, right? Get the full history. Now, because you have this whole history of changes, you can get great reporting too. Reporting about like the files that change the most often, who commits the most often, and those type of things. And so thanks to that data, you can make some like good data-driven decisions about your code base. Now with Git, you get a time machine. This time machine is like the Git checkout. You can go like Git checkout 2 months ago, and boom, you're like, you can see the code as it was 2 months ago. And by time machine, you can also change what happened in the past. So you could like Git checkout this and make like a small change, and then replay all the commits up to today and see how the code behaves if you do that. By doing this, you basically rewrite history, and it can be useful at times. And last but not least, Git is distributed. So you can have multiple people working on the same code base, performing changes in parallel, and then somehow figuring how to merge everything together. Think a minute about like how life would be, or how life was, when there were no source version control, like Git or SVN or CVS. I actually have a friend of mine who works on an application that's been maintained for 40 years, I think. It's in COBOL. It runs on a mainframe, and they maintain that code base as they've been doing it for 40 years, so no Git. So what they do is that basically they go in the code base. When they want to change some code, they copy that code, they comment out the old version, and then they add change number 1 to 3 by this person on that date with why they did that. So basically the code base is 99% old code, dead code, commented out code, and it's pretty tough. I was like, this is crazy. But, so it would look like this, right? If we had to do that day, it would be like, all right, so here's my change number, updated at, by, the reason. You can see some things in like the backup of the database or something. Anyway, here is the old method and the new method. So back to the, this is crazy. But that reminds me of that, actually. When we think about our database, when we build our database, we end up doing a lot of this, right? We end up adding like a deleted at timestamp and deleted by user ID and admin ID and the deletion reason and rejected that and so on. And so over time, because we need more and more of that knowledge for debugging reasons or reporting reasons, we just add all that by hand. And there is no way to go back in time and know which admin deleted a record a couple of months ago. So not so in the end. Cool. My name is Philip Crew. I'm a software engineer at Kickstarter. We have a small office here in Vancouver. And sometimes we have this beautiful view from the office, which is nice. Happened once. And today I want to talk about event sourcing on Rails. I should say this is Kickstarter's take on event sourcing. I wrote a blog post about that whole thing, and some people disagreed with some terminology that we've used or the way we do things. So anyway, that's our take on event sourcing. What is event sourcing? Martin Fowler has a quote for everything. And he says that event sourcing is that all changes to an application states are stored as a sequence of events, which is good. But the thing to highlight about that is that it's not as you change the state of your application, your data, you store an event saying the data has changed It's actually the other way around. You store that a user has performed some action or a system has performed some action, and based on that, you change the application state or the data that you have. My quote is, event sourcing is to data what Git is to code. That's how you get people interested into event sourcing. So event sourcing, our event sourcing framework has only 4 components, and I will talk about that now. First, events. Events are user actions that can be, so a user publishing a post, for instance, that can be an API call, can be some sort of callbacks, can be like a side effect. All those things are events. And they are persisted in the database, and they are immutable. So let's go through that. Let's think about an e-commerce platform, because everybody knows what Amazon is. So let's do that. So let's see some events that we could have in our database as someone browses a site to buy some things for the summer. So the user goes on the website and he finds a nice T-shirt and he adds it to the cart. So we have an event, T-shirt added, and you can think that this event has like a lot of data associated to it. The T-shirt, the time it happened, the user, the browser he's using, his IP, maybe not because of the GDPR, but those type of data. And then the user like finds a hoodie, and so he clicks on that like add to cart button, and we have a new event, hoodie added. And then we have some sort of system event that tells us that like a promo has been displayed, saying that the third item is 50% off. Magic! The user adds a T-shirt, another T-shirt. And then he checks out. And then the day after we ship the order, and the following day, the order is delivered. So that's like the whole life cycle of the order, unless he doesn't like the T-shirt and returns it, obviously. So those were the events, right? That we store in database, and that's what we have. And so we know what happened, when, who, etc. Now, let's talk about aggregates and calculators. Aggregates, that some people call projections, but I will call them aggregates. They represent the current state of the application. And calculators, what they do is that they read the events as they come through, and they update the aggregates accordingly. So it would look like this. We have a small calculator thingy, and that's the C circle, and an aggregate down there. So as the first event flies through, the calculator will update the aggregate, which represents the order, and we'll just say that this order now has 1 T-shirt for $29. Then the user adds a hoodie, so we add a hoodie, and we update the total. Promo displayed, we don't do anything with that. T-shirt added, all right, so we update the order. Now there are 2 T-shirts and 1 hoodie. The user checks out. We don't need to update the order, or we don't want to. And then the order is shipped on June 7th, and then it's delivered on June 14th. So as the events go through, the calculator updates the aggregate. And when you think about it, the aggregate looks like what you have in a regular application, right? That's the data that you have, which represents the current state of the application. But you can have more than one calculator if you want. So you can have another calculator that will create another aggregate or another projection that will represent the daily sales. And so you can have like different aggregates for different usage, whether it's like you could have an activity feed, for instance, using a different calculator, etc. And last but not least, reactors. Reactors, they react to events as they are created, and they can trigger side effects and create other events in turn. We have 2 reactors at the top. We do that again, T-shirt added, perfect. Hoodie added. And then we have a reactor up there that reacts to hoodie added. So basically this reactor must have an internal state that checks how many items you have in a cart. And as soon as you have 2 items, it will display promo and create an event to mention that the promo has been displayed. And then the user adds another T-shirt, and he checks out. Yay! This other calculator is super happy. He can update the daily sales. and then the order is shipped, and we have another reactor that will react to that shipped event and will send an email to the user to confirm that the order was shipped. And then the order is delivered. So those are like our 4 components. We have events, they provide like the full history of things. We have aggregates that represent the current state of the application. We have calculators that read events and update the aggregates accordingly, and reactors to trigger side effects as events happen. All right, why event sourcing? A lot of reasons. First, thanks to events, you get a full history or a full audit log, which is quite nice when you have to support real users using your real application for years and years. You can replay events. So I didn't talk much about that, but you can update your calculator. Don't update your calculator. Let's talk about the time machine. Time machine. You could replay all your events up to 2 months ago and see how your aggregate looks like. So it's basically, it will show you the state of the application as it was 2 months ago. You can also, it's very nice to replay events too when you want to fix a bug that you have in your calculator, a time zone bug, for instance. And so you can then feed the calculator with like all the events that have happened since the beginning of time, and your aggregate will be updated with the data that's now fixed. It's great when you want to add or remove attributes to aggregates so that you can backfill things. Recently, we work on like a subscription-based system, and we needed to know when a subscription was deactivated. We need that data to be on the aggregate. And so we just added that column, and then we updated the aggregate so that when and then we updated the calculator so that when the event deactivated happens, we store that timestamp into the database, and then we replayed all the events, and boom, the data was there. We even fixed issues where we were hard deleting records, and we figured that we wanted to soft delete records, so leave them in the database with just like a deleted add timestamp. By replaying the events, we had our records back in the database. That's the kind of like aha moment. You can decouple the data you write to events from the data you read from aggregates. So what I mean by that is that your events can have a lot of data that you don't need now, that you might need later. But then you can architect your aggregates so that they only have the data that you need right now. And over time, you can add columns to the aggregate or remove columns, change calculators, replay events, and get more and more data into your aggregates if you need to. If you need to have like high performance reads, you can do that. You can have an aggregate that represents your orders. You can have an aggregate that represents like a daily activity feed. You can have an aggregate for all sorts of use, and you can tailor them so that what you basically display on the screen is exactly what's stored in the aggregate. And so you can denormalize the data as much as you want because your source of truth are your events, not your aggregates. And I won't get into that, but it's great for distributed or service-oriented or asynchronous architectures because you can have a lot of events, throw them around, and then asynchronously process them and update the state of the application. Event sourcing at Drip. So what is Drip? Drip is a platform to support creators' practice. It's a subscription-based platform that Kickstarter has launched back in November. And so when you go to d.drip, you can find a lot of great creators, about 100 creators that do a lot of different things, and you can support them. And to thank you, they will send you some content. It's very similar to Patreon. It's just a different kind of users that we are working with. I would like to talk about the context because the context around how this project was created and the way we design our framework has a lot to do with, well, the decisions that we've made along the way. So, Drip. I joined Kickstarter in April last year. And when we joined, supposedly we had 1 month to ship something that was a brand new product separate from Kickstarter. on week 1, they told us that we actually had 6 months to ship, and that it would be part of Kickstarter.com. So it would be right built into Kickstarter.com, the monolith. So Kickstarter.com being a Rails monolith, there are like a few services, but it's mostly the website is a Rails monolith. Drip ended up being an engine within the Rails monolith. And it's been decided that the backend, the Rails app, would basically just be a backend that would offer a GraphQL API, and that some fine folks would work on the client side, so both iOS, Android, and React Apollo, and all that goodness. The approach. I guess it's just when I started at Kickstarter that I got very interested into event sourcing. And I was lucky that someone who's just joined Kickstarter had done some event sourcing by hand type of thing before. So we pitched event sourcing and they agreed that we would do it. But we knew that it was just an experiment because who knows, it could just break and not work out. So one of the requirements was that it should be easy to basically remove all that event sourcing craziness and switch back to a Rails app within like a week or 2. Okay, quickly. It should be easy to switch back to a regular architecture. It should be easy because we only have 6 months to ship. It should be easy for an engineer to work with it and like a Rails engineer to understand what's going on and how to add more events and aggregates and so on to that event sourcing framework. So for the implementation, we decided that this event sourcing thing would not be surfaced through GraphQL, so that if we had to rip it off, it would just be a backend concern. So the front end doesn't know that there are like events and aggregates and stuff. It looks like a regular API to them. We've built an event sourcing framework ourselves based on top of Active Record. There are maybe six-ish, 4, 5, 6 event sourcing frameworks in Ruby, and some of them use Active Record. Most of them, though, had some downsides. Some of them were quite hard to understand. Some of them had like 14 components to them. Others would have aggregates that weren't definitely shaped the same way you would shape a regular Active Record model, so it would be like very hard to remove. One of them, you would have to take down the application so that you could replay events. Wasn't great. Anyway, so we decided to just go with something simple, and that's what we are still using, actually. So aggregates and events are just regular Active Record models. And the aggregates, as I said, there are a lot of regular in this slide. I'm sorry about that. Okay, I'll fix that someday, some regular day. Aggregates are shaped like Rails application models so that we could remove the event sourcing side and just read from it. And each aggregate table has an events table associated to it. The goal there was to mitigate the risk of having like one event table that would have all the events for all the aggregates. So if we have, for some reason, an aggregate or an event table that's very noisy and has a lot of events and that slows down the performance, we knew that it would be only, the issue would only affect one aggregate and not the whole system. And basically all the events table have the same shape. They have an ID, an aggregate ID. They store some data as JSON, some metadata, IP addresses, user ID, etc., as JSON. And there is a created at timestamp too. And events are created and applied synchronously. So that's just to simplify things. You know that you won't get into like a half applied state where you have an event in database, but you failed to update the aggregate. If something fails along the way, everything is like wrapped in a SQL transaction, so nothing will happen. And we have what we call a dispatcher that connects the reactors to events. So you can like subscribe specific reactors to different kind of events. Yeah. Do you want to see some code? Do you want to see some code? All right. Oh no, this slide is broken. No, it's not. The fan is going like crazy right now. All right. I will just show you some code for like the aggregates, events, etc. So that's a sample aggregate. Like it's a subscription that we have on Drip. And so it belongs to a user, reward. It has many events. And when you look at the table, it looks like a regular active record, model, and table. So subscription can be like active, unpaid, past due, canceled, etc. We use Stripe to manage subscriptions, so we store the key in there. Yeah, and we have a few timestamps. And that's where you see the data that we need to display to the user when we rate the subscriptions. So here you have one type of events for subscription. So you can see that it inherits from a base event for the subscription. So we use single table inheritance. And so basically all the events that apply to subscriptions are all stored in the same database, in the same table. And we have a type column. That's the type of the event that's stored. And what those events have, there is like a very small like sugar data attributes that helps you define all the attributes that you want to store into the data column, and it creates like setters and getters for those. And then there is this apply method, and the apply method is actually the calculator. So we've decided for now to embed the calculator in the event itself, so that it's just like easier to like browse things and understand how things are connected with one another. But you can imagine that whenever this event is created, we then call the apply method on the aggregate, and that will, in this case, set the Stripe key, set the status to active, set activated at to the time that the event was created at. It returns a subscription, and then we persist that model in the database. So it's pretty simple. So I don't have a slide for that, but you can imagine that basically what in your controller would be subscription.update Stripe key, status, and activated at. Instead of that, what you do is you create the event, and that whole like update content goes into that one method. And you have some like events that we have in database. You can see that they have like their own IDs, the subscription ID, so subscription that they are associated with, different type of events, and then the data. And so each event will have a different set of data. So it's stored as JSON. And some metadata, user ID, notification ID, mostly the metadata for debugging purpose. And then the timestamp created that. The reactors, at the bottom, you have the dispatcher. And so the dispatcher is what we use to connect events with reactors. So we can say that on a specific event, like activated, send a subscription confirmation to the pledger or the backer, and send a new subscriber notification to the creator. All the reactors, they all just respond to the call method, and they take an event as a parameter, and they do something. In this case, they send emails. Back to the dispatcher, there is, you can see that I use the async keyword. We either have like trigger or async. So trigger is for synchronous changes, and async will just like queue that reactor in the, or that order to the reactor, whatever, into Sidekick. The idea of the trigger, so the synchronous way, is when you want to trigger a side effect synchronously on other aggregates. So for instance, on Drip, you can only have one pin post at a time. So whenever you pin a post, we react to that event, and we go over all the posts, and we will unpin the other posts that are currently pinned. And you want that to work synchronously. And comments. So before creating events, you want to make sure that you can create an event at that point in time, and that's what comments are for. So back to the controller idea, when a user performs an action like subscribing or let's say publishing a post, the controller will call a command. The command will figure whether you can perform this action or not at this time, that the attributes are valid or not, and if they are, it will create an event. So this command, we use it when we get a webhooks from Stripe. It's not very a good example, because when you get a webhook from Stripe that tells you that the subscription has been activated, you'd better store that event and process it. There is really no way to say, no, you're wrong, you cannot activate at this time, because it should just be stored as an event. But anyway, that's mostly the commands. We use them for user interactions more than other system or API callbacks interactions. So this command, we define a few attributes. You take a subscription, a Stripe key, some metadata. We validate that the Stripe key is present, and we build the event. And there is this no-op. We get a lot of like, the no-op being basically, don't create an event if the subscription is already activated. And you can get that when you have duplicate webhooks, or when, I will just get to that in a second. In a minute. Okay, I will get to the more complex part of the comments at some point. So we are 7 months after launch. We have a lot of events. Not that many in the end. We have 15 aggregates, about 120 different event classes defined, 40 reactors, 60 comments. And from a data standpoint, we have 35,000 aggregates stored in the database and about 250,000 events. So we are not at like a big scale so far. So performance are okay, but who knows in a year from now how it will be. Some aha moments. Replaying events is awesome. So as you've seen, there is this apply method in the event. And so you can just take an aggregate, take all the events associated to the aggregate, and then run through all those events and apply that method, that apply method to the aggregate. And that's how you replay events on an aggregate. And so to add column, it's been fantastic. To restore hard deleted database entries, as I mentioned, it's been great. And we run into like a lot of small calculator bugs. And it's nice when the data that you display to the user is not that right. And you can just fix the calculator, replay all the events, and the data is back into a good shape. You get all that nice reporting for free, kind of free, because since you already have, since the events are the first-class citizen in your code, it's very easy to have a reactor that just like send all the events to a pipeline, like ELK in this case, or InfluxDB, and then just have some charting library to read those events and react and display charts and do reporting on them. On that note, I think the biggest reason why I wanted to do event sourcing was actually for that reason. There are a lot of code bases I've worked on where you see some like send events to, I don't know, Google Analytics or to your whatever event bus you're using, or to Mixpanel. And you see like a lot of those like send events like everywhere in the code base, because you first got an application to work and then you want to monitor things, and maybe marketing wants to monitor some data stuff. And really often the code is just like cluttered with those events. Really often the data is wrong because nobody's really like making sure that the data is valid on the other side. So that was one of the key reasons for me, was to make events first-class citizens, so that when the data team wants to have events, they are already there and I don't have to think about them. Some aha moments too. It's great for admins and for debugging to have like this full history of events. So that's events for a subscription. So it starts at the bottom. You can see that the subscription has been like created and then activated, then an invoice was sent, collected, another invoice was sent, but the credit card got declined. So the event is now past due, so that subscription is past due. And then we failed to collect 3 times, and that switched the subscription into unpaid. And so it's just great to have all that, and we have that on like all our admin UI, and it helps a lot for mostly for support. It helps a lot. This idea that events can store all the data that could be useful at some point is very nice because you don't have to argue about should we store that data in the database or not. You just store it because it's almost free. And then later on, you can update your aggregates to if you need to display some data to the end user. So you don't need to like future-proof your aggregate. Like, maybe we need to store the reason why, or maybe we need to store which admin has performed an action. You know that all that data will be in your events, and you can later on surface it to the end user if you want to. The challenges, the not so aha moment. There are a lot of events and they are immutable, so you need to get your name right. And those are kind of very long meetings where there are times where you have like aha moments about naming, and sometimes you're like, still not right. And yeah, and when you know that a name is confusing, it's not just like code that you can change, like you can just rename a method, too late, or you can rename a service, too late. It's like an event in the database with a name. Now, we use MySQL, and actually currently nobody's really like reading the events to perform some reporting, so we can still go back and rename them if we want to. We've done it once, I think. Oh, yeah, naming is hard, that's what I was saying. And yes, that's the part that's pretty hard, actually. Destructuring GraphQL mutations into end comments and events is complex. Let's talk about that. Say that your user wants to update a post. So he has a form with like the post has a title, description. There is a Boolean that you can change to either like publish or unpublish the post. You can change the reward associated to the post and the attachment. Now, the API is made in a way that you could call update post with just the description. So you don't pass the title or anything else, just the description if you only want to change the description. But it's a form. So most of the time you actually send everything. You will send the title, the description, etc. And you have to figure what has changed so that you know whether you have to create an event or not. And so that like one GraphQL mutation turns out to be consumed by like 5, actually it's more than that, but let's say 5 different comments. One that will figure whether the title has changed or not, the other one description has changed, the publication status has changed, the visibility, attachment, etc. And then based on that, you will or not trigger a lot of different type of events. So it's basically what you get for free with Active Record, where they do like dirty tracking. So on Active Record, when you change a model, you can ask which attributes have changed. We basically end up having to do that by hand to figure what has changed, to figure which event we want to create. One simple example is when your post is published, every time you update the post, published will be set to true, but you don't want to like create published event every time that value is true. You only want to create that event when the value has changed from false to true. And it's not hard. It's just the most complex part of the application right now, actually. And in the end, it's not that complex. Let's wrap up. So we ended up creating like a simplistic implementation of event sourcing, but that's still working fine. I say 3 components. Yeah. There are aggregates, regular models, events with built-in calculator, number 2, and reactors. We use regular again. SQL database, and all the updates are synchronous and atomic. It's only the side effects from the reactors that don't need to be synchronous that will be performed asynchronously. Homemade framework, 200 framework, 200 lines of code, and yet it provides great benefits. We get like a full history and audit log. Updating aggregates and backfilling data is easy. You know when you are on your Rails app and you have to add a column and then you write some like custom script to go back and figure what the values are, and you add that to your migration and you hope that it will work. Well, with event sourcing, you just update the calculator, you replay the events, and it's done. So it's nice to not have to do those two sides, write the application code to set the value and write the script to backfill the data. Fixing bug is easier and there is less risk of losing data. It happens sometimes that for some reason we go on an, when you go on your model in the console on production, obviously, and you go, all right, let's, for all the aggregates where the country is set to FR, set the currency to euro, and you press enter and you figure that something is wrong and you've just said like euro on like all the records in the database. Well, at times you can fix it, but because you have those events that are immutable, you know that at any point in time, if you mess something up, you can replay them again and over again and fix the calculator over and over again if needs be, and sometimes needs be. Yeah, and events can be sent to your favorite analytics platforms for almost no cost, which is nice. So event sourcing on Rails, yeah, 100%. And that's about it. Thank you very much.